Please tune into our feed on the Delta Lake channels. We have YouTube, we have LinkedIn Live, we have Linux Foundation webinar as well. So if you can tune in there and ask your questions, we will take the questions throughout. Quick reminder for those who are new to the session, Delta Lake office hours happen every 2 weeks and they are live. And if you miss out any session, we always record it. So you will have like recordings available afterwards as well that you can share with your friends, your teams, etc. We keep it to like 9 a.m. Pacific time. And then we bring a lot of contributors and champions of Delta Lake to answer your questions and also share some of the important content that we get from the community. So if you missed any previous AMAs, I definitely encourage you to check them out on our YouTube or LinkedIn. And in the meantime, I would love to see where you are rolling in from. If you are attending our LinkedIn Live, please feel free to ping there. Love to see participation from all over. Awesome. Today, I am joining live with my guest from Austin. And, just while you are dialing in, I want to give a mini recap from the last session. That was like the last session of 2022, and we had an engaging discussion on the Delta Lake projects. So we covered 3 different projects within Delta Lake, which was Delta Core, Delta Rust, and Delta Sharing. 3 of the Delta Lake contributors were covering the features and community momentum, Florian, Will, and myself. And today we have an awesome guest speaker, Anup. My journey with Anup goes back more than 4 years, where we were just getting started with Databricks. So it has been an absolute pleasure to work with him. And today I have like definitely a very lucky day because I get to host him today. So we are going to bring lessons learned throughout these many years of journey. And, I'm super excited to have Anup on this community office hours. So Anup, why don't we kick off with introductions? Why don't you tell us what do you do? What does Yipitdata do? Let's get started there.
Awesome. Yeah, thanks, Vinny. Thank you all for having me here too. Just to introduce myself, my name's Anup Segu. I'm the co-head of data engineering at Yipitdata. I've been there for about 6 years and helped found their data engineering department and practice. And we've come a long way over those years. We've been a long time Delta and Databricks user. I think we've been using Delta Lake since around 2020. So definitely had a couple of years of experience working with it, and it's been fantastic so far. In terms of just a quick recap of what Yipitdata does, we are a data insights company. We help investors and companies make better decisions by leveraging alternative data. And so our data teams source data sets from all across the world, from a variety of public data sources, proprietary data sets, and licensed data sets. And we bring all of that data in, we try and transform it, make sense of it to answer key questions that our clients have about the markets that they operate in. And so, yeah, I think Vinny bring up this architecture diagram. So just to kind of give everyone a little bit of a mental model of how our company works. On the left side, you can think about all of the different data sets that are out there that we want to procure to help answer questions for our clients. And so we bring all of those data sets inside to our product teams to then utilize. So our entire data platform is built on top of Delta Lake, Spark, and Databricks. And so every single one of our product teams will be ingesting these data sources, trying to transform them, kind of making a bronze, silver, gold ETL pipeline so that they can produce clear and rich data insights that can then go to the right side, which is our data product. So our company typically provides their services in the form of research reports, but we also have over the years more technical ways to consume our product. So that can come in the form of interactive dashboards, a client portal, programmatic, data deliveries, even exports to different data warehouses. And so we've really tried to cater to our clients and give them as much ability to work with the refined data that we can produce. But that all kind of happens by being able to kind of pull the data in from different sources, helping these product teams have kind of autonomy to be able to work with those data sources, make it easy as possible to transform that data. And I think that's really kind of the nature of how we're able to kind of produce value for our clients.
That's really valuable, Anup, what you shared. A quick overview of like how data engineering works at Yipitdata and kind of sharing like some of the journey that you took throughout, this architecture, setup of this architecture. So my question to you is like, you have like this complex, of course, we shared in one slide, but it's like a very complex merge of different teams, different tools. So definitely you had to put a lot of thought into, how to go about architecture. So can you give some pointers on why you made some of the architectural decisions in that data platform?
Yeah, absolutely. I know just like even looking at that diagram, it feels complex, and the reality is it's even more complex than just that. So just to kind of put it in perspective, our data team's around 250 to 300 people. And today, the size of the Delta Lake that we have is around like 14 petabytes and like 150,000 tables. So we're working with a lot of data. A lot of data is in motion at any given point. Our teams are kind of organized, and we're trying to take more of like a data mesh approach where we have different data teams be experts in their domain, try and produce refined data sets and either distribute those data sets internally to other teams or go to clients depending on kind of where they fit within the organization. And that process has worked well in terms of just being able to orient people. A key part of our business is our ability to really answer tough questions that our clients can produce answers through their own data teams. And so to be able to do that, we need these data teams internally to be as autonomous as possible, to be able to kind of work with data as far up in the chain as possible and be able to pull as much insights and extract as much value out of it. And so we don't necessarily see, data engineering as kind of a important step in that chain. In fact, we try to remove ourselves from that feedback loop and try and give these data teams as much kind of independent capabilities to work with the data, because we don't want to necessarily slow down their process. A big part of why our product's valuable is we can acquire the most valuable data sources. We have technologies available to our data team so that they can work and reshape and restructure that data to make sense of it. And they can produce all of that kind of data insight on a really dependable time frame where it's basically actionable for our clients. So there's like a time component, there is a quality component. And so for all of those reasons, we've built this data platform so that the data teams have standard set of tools to be able to work with the data no matter what kind of source it might be coming from. One, we need to make sure that they're able to do their job, but two, it needs to be able to be done on whatever data source we have. There's so much variety where we don't want each team to kind of go out into the wild and come up with their own way to work with data, because that could create a lot of complexity internally. We want everyone to kind of work with data the same way. To kind of bring it back a little bit to kind of Delta, that's really where we wanted to orient and have all of our data stored in Delta Lake, because that was a good way to make sure that people work with data the same way and they have enough kind of flexibility to work with data to do the job that needs to be done. So a lot of our philosophy has been push kind of the ability to do data operations to our data teams, our data analysts, keep the tooling consistent across different teams, and be able to kind of leverage technologies like Delta so that they can do a lot of stuff and it's very consistent across whatever data source or client kind of request they might need to encounter.
Yeah, so Anup, just let me dig in a little bit on the source side. So you mentioned that you have tons of data. I can imagine like, to build the financial reports, the data is coming in from variety of different sources. You do like a lot of web scraping and all that stuff. So what kind of things goes into like, what kind of data do you deal with, and what are some of the engineering things that goes into building and, collecting all that data?
Yeah, so on the ingest side, big challenge is kind of variety of data sets that we're encountering. So as you had mentioned, we do a lot of work with public web data. That was kind of historically been our bread and butter. So we collect petabytes of data from the internet and use that from those kind of public data sources and ingest them into our platform. We also work with proprietary data sets internally. So we have kind of an e-receipt data set that we've been producing and growing. And we have licensed data sets that come from a variety of data vendors, and that can encompass a number of different industries. Some are more specific to an industry, some are more about just kind of general consumer trends, general market overview type information. And so the thing is, with each of these channels, they all kind of work with data in a different way. Public web data is completely unstructured. Our proprietary data sets, we have some more control over, so we can kind of keep them in formats that we are comfortable with. And then our licensed data sets, when they're coming from vendors, again, we have limited kind of controls over how they want to work with data. Typically, they will come in some kind of raw file format, so CSV or Parquet. And then in terms of just like the volume of data, it can range from hundreds of terabytes to metabytes, so kind of a wide spectrum. So that becomes like kind of just the data engineering challenge of like how to ingest it. And so the main thing that we try and do is focus more about how do we get this data into the Delta Lake and in Delta format, and not worry too much about processing the data at the ingest layer. So we don't do too many transformations there. We just want to take that data wholesale and get it into Delta format. Depending on like the type of channel, so there are tools for kind of working with CSV and Parquet and kind of just native file formats in Spark that will build tooling to kind of just make it really easy to ingest those files in Spark and produce a Delta table. If you're using Databricks, there's autoloader, so we use that a lot to kind of stream the more high volume file deliveries that we have. There's also some kind of solutions where if people or vendors that we're working with work in a certain data warehouse, like Snowflake, or as well as just kind of like working in a relational database, we'll use kind of third-party integrations to be able to read that data in from Snowflake or from the relational database and kind of put that into our Delta Lake. So Fivetran is one that we commonly use for those kind of patterns as well. So what we really try and do is identify just really simple, maintainable solutions and extensible solutions that can work no matter what the data is, to just bring that data into Delta Lake and then kind of work with the data, Delta onwards. And that's been kind of the main strategy, is like how we've been handling ingest.
Interesting. So Anup, you mentioned about like, you don't do a lot of processing at the ingest. What is like, how does bronze, silver, gold look like at Yipitdata?
Yeah, great question. I think this is a philosophy that we've really taken to heart for our data teams, and they've really connected the dots as to the value of it. When we're working with data sources on the ingest side, one of the things that we've realized is something can go wrong on the ingest side. And when it does go wrong, what do you do? If you do a lot of transformations on the ingest side, then you start introducing another variable in the equation. It could be the source of the data has an issue, or it could be your transformations have an issue. But if you mess up at that time, there's no way to kind of go back and see what that data looked like before. And so for our product teams that have kind of ongoing deliveries going out to clients, this kind of fidelity and reliability is really important to them, because they need to be sure that like if they're sending something to our clients, that they can go back and see the source data and make sure it is correct, or they can do follow-up questions or anything of that nature. So we really try and emphasize, we don't want to do any transformations at the ingest side, bring it into Delta. The nice thing with Delta is you keep like a transaction log of all the data that you're onboarding into a Delta table. So we can see the history of the ingest just by using things like time travel and things of that nature. So it helps a lot, because it just gives people more confidence internally that the data that they're bringing in looks like something at a certain point in time. And then they can kind of depend on that protocol, giving them consistency moving forward. From there, then like there's a lot of transformation that happens in the silver and gold pipeline. And I think that's really where we kind of push the data teams to kind of build whatever pipelines that you want, continually work in the Delta format. But if you mess up at the silver or gold layer, that's fine. You still have the bronze layer to go back to and redo your pipeline, fix your mistakes. And that's been a great way to kind of really protect our data assets, protect kind of the pipelines that are going out to clients, things like that.
You brought a very good point here, Anup, is data access. I think a lot of organizations are still thinking about how they structure, access levels for each table, so that both their use cases are done properly. They have the data that they need, and also like put some guardrails together, right? So you did talk about like how you have the control for downstream users in the silver and gold layer. So is my understanding right that downstream users are product managers and BI analysts who has access to, probably silver and gold layers, and bronze layer is something that only data engineering teams maintain?
Yeah, it's kind of evolved. I think that was definitely
Mhm.
our underarching idea. Like, yes, we want to protect the bronze data and make it very difficult to be able to delete or corrupt that data. And so for a lot of our bronze tables, they will typically be read only for many teams. And one thing about the bronze, silver, gold that I should mention is we see it as a philosophy, but because of our kind of data mesh type our approach, one team's kind of gold table might be another team's bronze table. And so it's kind of like this self-fulfilling cycle. So even for the gold tables that one team produces, we make them read only for another team that might be consuming it, just so that there isn't a way for them to corrupt that data flow. So short answer, yes, we want to make the bronze level as read-only as possible for the appropriate teams. And so we see that at kind of multiple steps throughout our organization, but that's because, we have one team producing data for another team, and then that team's producing data that goes out to our clients. And that's kind of been the approach that we take.
Got it. That's pretty helpful, Anup. So I think you mentioned a very fair amount of complexity of your architecture, as well as some of the architecture decisions you made. I wanted to ask, what were some of the challenges before you had the scalable architecture? What were some of the challenges you were dealing with? And I think you already mentioned about some choices some choices you made for Delta Lake. So I just want to double down on that if you can.
Yeah, so I mean, kind of winding back the clock, before we were using Delta, our data lake was much smaller in size. We're also a much smaller company, so it was still quite large. I think we had like around 4 or 5 petabytes of data at that time, and we were storing all of that data typically as external Parquet tables. So in the absence of Delta, like our gold standard of like how to store data was Parquet, and that was like already like for the time, like it was pretty great. I think there's a lot of advantages to Parquet. I mean, Delta uses Parquet under the hood, but there were still operational challenges. So I think a few of the key things that we were seeing, data retention was a real challenge because we would have pipelines running every day like we do now. They're overriding tables, and because we don't really have a protocol like Delta, like a transactional kind of system, we don't really know if we can guarantee that old versions of tables are available to restore in case people make mistakes. We did have custom tooling that we built inside to kind of give people the illusion of a versioning system, but it wasn't necessarily ironclad. I think it was very hard for us internally to guarantee that those versions of those tables were available, or if they weren't, the reason for why that retention process failed. And so a lot of that internal tooling was just having a hard time scaling. And as our data lake get larger and larger, those were kind of custom processes, operations and Spark pipelines that we were maintaining in data engineering that just couldn't keep up with the volume of data that we have. So that was one large challenge. We were also doing a lot more work with raw file formats. So people would be creating external Parquet tables, sometimes be creating tables with CSV format. There wasn't any unification of how people should be organizing their data, and that could produce a lot of challenges in performance and kind of the quality of the data itself. So things that could happen in raw file formats that would often bite us, data corruption, schema drift, difficulties. Like if we wanted to use streaming, using streaming in the absence of Delta is much more difficult. So a lot of these kind of options to be more performant and be more reliable with their data pipelines were off the table because we just didn't have a solid kind of like storage layer. And so when we were looking at Delta, I think at that time, one of the key things we were looking at is like how to use streaming. And so that was kind of one of the big momentum shifts. Like we knew that like our Parquet kind of data lake wasn't scaling, but wanted to use streaming in some situations. And so we first kind of switched to Delta, and then that kind of made the streaming and the data retention much easier to manage.
Got it. I think you brought a very good point on streaming. Throughout my conversations with different data engineers and data scientists, there is always this myth that streaming has to be, they always associate streaming with real-time processing. But in reality, it depends on your use case and how you process it, right? So can you share your perspective on that, like how Yipitdata thinks about streaming?
Yeah, absolutely. Great question. I think we've from kind of the inception, we never really looked at streaming as a real-time solution. But what we were looking at streaming for is we have large volume data deliveries from some of our vendors that are coming. And even though they are large volume, historically on like a daily interval, it might be like a few gigabytes that they're delivering every day. The entire table might be hundreds of terabytes. So we ran into a problem because if you're not using streaming, you're using batch, where if you want to do transformations, you have to read in terabytes of data only to process, on each day, net new a few gigabytes of data that's been added. That was really inefficient, expensive from a compute perspective, would break down if you don't have enough compute in your Spark clusters to handle. And so streaming just made like a much more sense conceptually as to like, yeah, we should only process the data we just received. But it can be difficult because I think a lot of the documentation and kind of guidelines out there were designed around a real-time kind of data flow. So something that we learned early on that in Spark streaming that's pretty cool is you have this option of using triggers like trigger once, or I think more recently trigger available now. That can help
Available
kind of,
now, yeah.
yeah, that can help control a stream so that you only process the data that has been made available to that stream, and then it stops the stream and shuts down your compute process. And so what we saw with that was like really substantial cost savings because you don't need to keep the streaming cluster up 24/7. You only work with just a few gigabytes of data that you care about. But then from there, I think what we've really seen over the long period is that really introduces reliability, because you don't have to worry about like if all of a sudden, it was tens of gigabytes delivered or hundreds of gigabytes delivered, your stream just kind of handles that process. You don't really need to think about it. And you're not necessarily having to like, run the entire kind of data process on the entire data set, which is going to be really risky, prone to failures on your Spark cluster. So the pipelines that we've moved to streaming, and we've done it well, we've seen that they're just much more reliable and fault tolerant. I think today, like that's how we see streaming and internally is, do we have like a large volume data set? Do we want it to be highly reliable? Let's consider streaming in those contexts.
Got it, got it. That's really helpful, Anup. I think on that note, I want to understand how you know, what does the frequency of data processing look like? Is it dependent on the application, or, like, do you have 3 hours window when you process the data? So how is that frequency? How does that frequency look like?
Yeah, it really, it's a spectrum. I don't think we're necessarily taking for each data source the same approach. And part of
Mhm.
that is ultimately like, when is that data made available? For our vendors, that might be, a daily delivery or weekly delivery, monthly delivery. And so that will dictate the cadence of when we run our ETL and process our data. Some of our more high volume data sets, we'll process every day. And then occasionally we might be processing a few times every day. I think that's more for like internal data sets, like internal logs and things like that, where we need to keep like more closer to real time, but not quite real time. I don't think we've necessarily quite reached a point where real time is necessary. It's kind of a nice to have, but that's been kind of like where we have seen a good balance of cost control slash, recency of your data.
Got it, got it. So, some of the blogs that, you wrote, Anup, and, Steve and Andrew wrote, I think some of the things that are really valuable when I am giving references is like, cost savings. And you did mention that quite a lot during our conversation. So can you give some tips to our viewers? How do you manage and keep your cost efficiently while running at scale?
Yeah, costs are always, I think, top of mind for any organization right now. I think if you're using Delta, and I'll try and focus on just kind of like cost optimization for Delta Lake, I think there's two variables or two drivers of cost. One is storage overhead and one's compute overhead. The good thing is, I think there are techniques that Delta offers to provide solutions to both. I'll start with storage. I think the biggest surprise for people that are just using Delta Lake might be like versioning is awesome, that it's baked into the tables, but that can really start adding up and accruing on your storage layer because each version is just a new set of files for that table. So if you don't really have like a data retention policy in mind or think about that actively, that can be really surprising. And we've even seen situations internally where we had a Delta table that was updating and someone forgot to vacuum it. And all of a sudden it's like massive in our S3 bucket, but really the table is small overall. So some things that Delta offers, use vacuuming. We basically have written kind of tooling internally, like when someone creates a Delta table or overwrites it, we just vacuum it automatically based on a retention window we're comfortable. Other things that are on the storage layer that's interesting, we've used a lot of auto-optimize and auto-compact, and I think that's been a real advantage to the storage layer. One, it helps kind of keep your Parquet files in your Delta table more compacted, so you get better compression. But the other kind of benefit is it reduces the number of kind of S3 get and put operations or whatever cloud storage layer you're using. So that IO gets shorter, which is kind of another kind of line item typically for cloud services that you'll get billed on. But we were able to kind of like drop those operations by maybe like 50% when we just rolled out auto optimize to like every single Delta table. That kind of has like a knock-on effect, which we'll get into compute now, is just your compute processing on Delta tables will typically be better because your files are more reasonably organized. You don't have to worry about kind of keeping things like repartitioning your files before you write it out or anything like that. Like Delta just takes care of it. But where we've seen on the compute side beyond just kind of auto optimize is you can use things like Z-ordering. So we've seen like in certain situations where you have very large tables, but people are querying those tables on certain sets of columns, Z-ordering can be super effective in bringing down the compute cost of those downstream workflows because you're really just paying for scan time on the Delta table. And so with Z-ordering, you just kind of erase that and make it very efficient. So we've seen workloads go from like hours to like minutes because we've Z-ordered on the right columns.
Wow.
But you have to like be very tactical in when you use Z-ordering. So it is a compute intensive operation, but it's kind of like an investment up front. You pay that compute ahead of time to organize your data. So as long as you're querying on those kind of Z-ordered columns, you get a lot of benefits, and that can have a lot of kind of knock-on benefits. So I feel like those are kind of some of the key things. There's also streaming, as we were talking about, that can be a path to cost savings. So using things like trigger once, trigger available now, can really make working with large Delta tables really efficient. And the nice thing is it's kind of all the same Spark data frame API. So it doesn't feel that different from batch if you're starting to use it with Delta.
Got it. Anup, you did mention about Z-ordering. I kind of want to dig a little deeper into that, if you don't mind. So it's very important when you use Z-ordering correctly. I think, you mentioned, how do you go about selection of columns for Z-ordering?
Yeah, it's something that we're still trying to get like a better handle on. So I would say one thing that we look at is, we first don't really think about Z-ordering unless we need to. So unless someone's really saying, or we see in kind of our Databricks usage, these workloads are really slow, we're not really thinking about Z-ordering actively. But where we do start looking at it is like, are there certain tables that multiple downstream teams are reading from? So like when we talk about that data mesh diagram, there's sometimes central data teams and then multiple sector teams that might be reading from those tables. And there might be just one set of tables that everyone is reading from. So those are great candidates because there's a lot of read operations going on. And then we look at how are people reading it. Oftentimes it's like we have a data set that kind of covers the entire US market, but then each of these downstream teams are caring about like one specific sector or company. And so we just have like Z-ordering on that company column or that sector column or industry column, because like that will help that filter be much more efficient. And so like those have been like some of the techniques that we've used. Another one where we've noticed Z-ordering helps a lot with is merge operations. So if you have like a streaming based or incremental workflow, like the columns that you're merging on, if you Z-order on, we've seen like a nice performance bump. But I'd say like it's very situational, and I think you don't need to over optimize unless you need to. So I'd say like always measure first, understand where your overhead is or where the bottlenecks are before you use some of these like techniques.
Wow, that's really helpful. Yeah, it's interesting how long we have come along, Anup. Back then, even at Databricks, we couldn't understand the scale our customers were running on. And I still remember, one of our support person reaches out to me and says like, oh, Yipitdata is running like this huge Are there chatbots or something? Because you were running like quite some experimentation on like, growing volumes of data. So I do remember our like scaling process. We had to scale our number of jobs, concurrent jobs, and a lot more. So it was pretty exciting to work with you, Anup, scaling those
Yeah,
workloads. So
absolutely. I think we've definitely grown together with Databricks on kind of understanding how to use Delta. A lot of these lessons that we've been talking about just in this talk, like have been coming from like guidance from Databricks, like solutions architects, PMs, people like yourself. So I think it's been definitely a growing domain area, and I think we're still trying to learn more about like how to make the most of
yeah.
Delta tables.
Yeah, I know there's still like more to do, and we are like just working constantly on new features, Anup. So thanks to a lot of user feedback that you have given over the years, it's been incredibly helpful. Awesome. Any other closing thoughts, Anup? I know we are running out of time, but
Yeah, I think I'll just kind of end on this. We've been very successful at using Delta. I think if you're kind of an organization trying to think about your data lake and how to organize it, I definitely advocate looking at Delta, and it really provides a lot of utility. I think for us, we've noticed is because it just kind of standardizes a lot of operations of how you work with the storage layer. There's just a lot of operational efficiencies. You get compute and storage benefits that we were talking about, just a real tailwind to your organization. So I would say like definitely strongly consider it if you are thinking about looking at your storage layer. There's a lot of benefits, and I think it's been surprising how much it's even grown from like when we first started using it to where it's now. And every time there's like a new feature that's rolled out to Delta tables, we're like so excited because every one of those like 150,000 tables can start benefiting from it. So we've really kind of subscribed to just that ecosystem. It's really done us wonders.
that's absolutely amazing, Anup. Yeah, thank you very much. Yeah, those are some of the amazing lessons, and I hope our community found this insight useful. Just a quick reminder, our office hours happens every 2 weeks, and for this month, we had this amazing session with Anup, and you definitely should attend next one as well because we will have Michael Amberst. I'm super excited for his session as well. So please do not forget to RSVP to our event, and I will definitely look forward to having more contributors and champions of Delta Lake to the office hours. So thank you.